Greetings and welcome to the first video on the Bug Halt YouTube channel. We are currently using text-to-speech while I wait on getting my podcasting kit properly set up. In future, some of our videos will be in English using my real voice, and those same videos will also be posted in French with a French-speaking friend of mine doing the narration. In certain videos, I will be discussing things that I did in the past that weren't necessarily legal. So for those videos, I will be relying on TDS for plausible deniability. However, the vast majority of my videos will be recorded using my real voice. In this video, we will be covering the basic fundamentals of using Linux as a tutorial for beginners. This is the first video in a multi-part series covering the basics of Linux, so we won't be going too in-depth here. We will be covering the following areas: an introduction to terminal commands and using the shell, an explanation of how privileges and permissions work for both user accounts and for files, an overview of Linux distributions and package managers and their differences in terms of both syntax and overall user experience, an introduction to desktop environments and window managers with examples of some popular ones, an explanation of and the differences between userland and kernel space, and finally some examples of different terminal shortcuts and shell delimiter characters. So let's get started. If you're someone who wants to get into cybersecurity, then understanding how Linux works, and more importantly how terminal commands work and what each command does is crucial in order to become competent. You need to know how to use a terminal and run Linux commands properly because the vast majority of servers you come across will be Linux-based. So if you were to gain access to something and didn't understand how to properly navigate around a terminal, then you'd simply have no clue what to do next. Many web-based vulnerabilities result in remote command execution, which is the ability to execute terminal commands on the back-end server. If you aren't familiar with such commands, then you'd have no idea how to properly exploit such a vulnerability. The terminal in Linux is pretty much the equivalent to command prompt in Windows. We will start out this video by covering some basic commands used for navigation as well as creating or deleting files. The commands in this list are just some very basic ones. The cd command stands for change directory and is used to switch to another directory. If you aren't familiar with what a directory is, it's just the equivalent to what we would call a folder in Windows. Next up, we have the pwd command, which stands for print working directory, which outputs the name of the directory that we are currently inside of. After this, we have the ls command, which is used to list the contents of a directory, displaying the names of any files or any subdirectories that are contained within that directory. This is equivalent to the dir command in Windows. Next is the makedir command, which is used to create a new directory, followed by the rmdir command, which is used to delete a directory, with rm standing for remove. After this, we have the touch command, which is used to create a new file. This is followed by the rm command, which, as we just explained, stands for remove. This is different from the rmdir command, as the rm command is used to just remove a file rather than to remove a directory. After this, we have the nano command, which is a command used to launch a basic text editor that comes packaged with Linux distributions by default. Finally, we have the cat command, which is used to output the contents of a file to the terminal. Let's demonstrate an example of these commands being used together. In our example, we will create a directory. Output its name. List the contents of the directory. Create a new file. Edit the file. Read the file contents. Delete the file. Navigate back to the previous directory. And finish up by deleting the directory that we created. On screen, you can see a terminal window. We will use the makedir command to create a new directory, followed by the cd command to navigate to the directory we just created. Now, if we run pwd, it shows us the path to the directory we are in. Running ls gives no output since the directory is empty. Let's create an example file and run ls again. Now we can see the file name in the ls results. We can run ls with flags to get more extensive results, but this will be covered later. Let's use nano to edit the file we just created, adding some example text so that it isn't just an empty file. Now we can use the cat command to output its contents, which will display the example text we just added. Here is an example of cat being used and the contents of our file being outputted to the terminal. Now let's delete the file that we just created and then navigate back to the previous directory. cd with 2 dots followed by a slash will cause the terminal to navigate back to the previous directory. Finally, we will delete the directory that we created. You might notice that the second time we ran ls, we added a dash character followed by the letters and L after it. These are known as flags, and they tell the terminal to perform more specialized actions. Almost every terminal command has unique flags that can be used to perform specific actions. To get information on the flags for each individual command, we can use the man command followed by the name of the command that we're wanting information on. This will show us the manual for that specific command, explaining the purpose of each individual flag that can be used. Some commands have lots of different flags available, while other commands only have a few. Almost every command has at least some flags, and many of these flags can be incredibly useful. Next, let's discuss file permissions. All files on Linux have different permissions, and these permissions tell the operating system what a user can and can't do with those files. The three main permissions are read, write, and execute. So for example, if a file has read permissions disabled, then you won't be able to read the contents of that file. Or if a script doesn't have execute permissions, then you won't be able to run that script. We can use the change mode command to modify permissions for a file, and we can use the ls command with additional flags to check file permissions. In this image, we can see our W and X are set, meaning we can read, write, and execute the file. Let's create a script to demonstrate how we can set permissions in order to allow execution of that script. First, we will create our script, in this case, just something basic that will output some text when executed. Now that we've created our script, if we try to run it, we will get a permission denied error. This is because it lacks execute permissions. In order to fix this, we can use the change mode command with the +X flag to enable execution permissions. To check whether the permissions have been set, we can run ls with the A and L flags, and from those results, we can now see the letter X, indicating that we have execute permissions. Now that we know we have execute permission set, we can try running our script again, and this time it should execute properly without any issues. As we can now see, the script is executing successfully, outputting the text inside of it. As well as file permissions, we also have permissions that are specific to users, although these tend to be referred to as privileges rather than as permissions. The root user account has the highest level of privileges, and although this is an oversimplification, we can think of this as like an admin account on Windows. This account type is also known as a super user and execute commands as root. We can use the sudo command, which stands for super user do. To switch to a root account, we can use the sudo su command, and we will be prompted to input a password to authenticate as a root user. Or to switch to another user account, we can use the su command to authenticate as whatever user we specify in that command. We can give any user account privileges equivalent to a root user by modifying the etc. sudoers file. A super user resides within kernel space, also known as ring 0, while a regular user account resides within userland, also known as ring 3. The rings between 0 and 3 are mostly for device drivers. The best way to visualize this is thinking of the kernel as the core of the OS. There's a reason why it's called the kernel and the terminal is called the shell. Think of a nut. In the middle of a nut, you have the kernel in the center, surrounded by a shell. The shell sits in userland, aka ring 3, which interacts with the kernel at the core of the OS in ring 0. The following diagram represents this concept, with green representing lowest privilege and red representing highest privilege. As you can see, the core of the diagram contains ring 0, which is where the kernel sits and has the highest privileges. The terminal, also known as the shell, sits in ring 3 and is wrapped around the outside, just like the shell of a nut with the kernel inside of the core of the nut. Almost all operating systems use this concept, and it's known as protection rings. In this next clip, I will demonstrate how the sudo command can be used to run commands that would require a higher level of privileges. After this, I will demonstrate how we can use the sudo su command to switch from our regular user account in order to authenticate as a root user, aka a super user. The command I am about to run here is using my package manager to update all of the packages contained within it, so that they are all their newest versions. Without using sudo to execute this command as a super user, the command would fail, as we would have lacked the necessary privileges that are required to run this. Downloading files in Linux works somewhat differently to downloading files in Windows, and while there are exceptions, many files are downloaded and installed by using our package manager to do so. Rather than downloading and running an executable, In Linux, we often use a package manager to download the software package that we are wanting to install. Not all programs are shipped with our package manager by default, and in situations like that, they can be downloaded and installed using other methods, but lots of common software packages are shipped with our package manager and can be installed by running a command related to the package manager. In the example that I'm showing, the Linux distribution being used here makes use of the apt package manager. Although many different Linux distributions make use of other package managers instead. If we are wanting to install a program, we can use the apt-get install command followed by the name of the specific software package that we are wanting to download and install. The command currently being ran on screen is updating all of our software packages and will take a long time to complete. So for now, I will stop execution of this command as I've already demonstrated how to run commands as a super user, which is the only reason why I ran this command to begin with. Now I will run the whoami command and the id command to display my current username and user ID. Now if I run sudo switch to a root user, running those commands again will show my new username and ID. We can see that my username has changed to root and that my ID has changed to 0. Root users always have a user ID of 0, which represents the highest level of privileges. A point that I feel is necessary to bring up is that if you are new to Linux, you should avoid running commands from a root user account until you have a solid understanding of what you're doing, as a root user can do practically anything they want. So if you don't know exactly what you're doing, then it can be fairly easy to accidentally break your operating system. It's best to stick to a regular user account and use the sudo command to run things as root if it is absolutely necessary to do so. But for the majority of the time, you should stick to running commands from a regular user account where you're not going to run the risk of potentially breaking your OS. In this next section, we will cover the usage of shell delimiter characters and other specific characters that have a unique purpose within the terminal. Knowing the purposes of these characters is absolutely crucial for learning certain aspects of web application security. And the reasons why this is the case will be made very clear in our upcoming OS command injection video. Certain characters allow us to chain multiple commands together or run 2 commands concurrently. Certain characters are used to take the output from one command and pass it as the input into another command, or to write the output of a command to an external file. In this next section of the video, I will demonstrate some examples of how each of these characters work by running terminal commands with usage of these characters. Let's say we want to change to a directory and read a file within that directory. Rather than running 2 separate commands, we can run both commands at once by separating them with a semicolon character. This helps us save time as we can execute everything within a single line of text on the terminal as opposed to having to run multiple commands separately. It's as simple as typing the first command that we want to execute, followed by a semicolon, and then the second command that we want to execute, so that they are both separated with the semicolon in between the 2 commands. So in this example, we are changing directory to the etc. directory and then reading the password file from within that directory. This will run the first command, immediately followed by the second command. However, what if we would prefer to run 2 separate commands at the exact same time? In order to do this, we can make use of the ampersand symbol instead of using a semicolon. The syntax is still the same, just instead of separating our 2 commands with a semicolon, we are separating them with the ampersand character instead. For the sake of this example, I will run a ping request against the public IP address for Google's DNS server, in addition to running a command to output some text at the same time as my ping command being ran. Alternatively, we can use what's known as the pipe character to pass the output of one command being ran to be used as the input for another command. This can be incredibly useful in many different situations, such as if you're wanting to run 2 automated scripts where the input for the second script needs to be based upon the output of the first script. In this example, I will use the cat command to output some text from a file, and then I will pass that as an input to the head command, which instructs the terminal to only read the first line of the outputted text from the first command. We can use flags with the head command to specify how many lines we want it to read, as seen in this example. Next, I will demonstrate usage of the greater than symbol to redirect the output of a command into a file, allowing us to automatically write the results of the command that we are executing to a file of our choosing. This can have many different uses, but one common use of this would be if you wanted to ensure that the output of a command was saved somewhere so that you were able to make a note of it and reference it at a later date. In this example, I will first demonstrate using this symbol to output some text to a file. Then I will run the ls command and output the results of the ls command to a file. So we've now outputted the word testing to a file via the echo command, and also outputted the results of our ls command to a second file. If we use the cat command to read these two files, we can see the results of our command outputs have been written to them. Alternatively, we can do this the opposite way around too, by using the less than symbol rather than the greater than symbol. This is far less common, although it does still have some purposes. For the sake of this example, we will use this symbol to redirect the contents of a file into the tail command, which does the opposite of the head command. First, we will create a file containing some text content. Then we will use the less than symbol to redirect the file to the tail command, which will result in the bottom lines of text from that file being outputted. Since we are using the 3 flag of the tail command, it will output the last 3 lines of text that are included within the file that we created. Of course, by modifying the value for this flag, we can control how many lines are outputted. Another useful thing that we can use is logical operators. This can allow us to make it so that the second command will only execute based upon whether the first command fails or succeeds. If we use 2 ampersand symbols combined, then the second command will only execute in situations where our first command is successful, otherwise it will fail. For this example, I will run 2 instances of the echo command to output some text, since I know echo will execute successfully. When our first echo command works successfully, our second command also gets executed. If we only want our command to execute in situations where the first command fails, then we can use 2 pipe characters instead of ampersands to do this. The syntax is still the same, with our commands separated by the 2 pipe characters in the middle of them. For this example, I will again use 2 echo commands, but since I know that the first echo command will be successful, the presence of the double pipe characters will cause the second echo command to fail as a result of the first one running successfully. If our first command had failed instead, then our second command would have ended up running successfully. Some other useful characters specific to the terminal are brackets, as these can be used to tell the terminal to execute commands in a specific order. We can combine this with other previously mentioned characters. For example, we could have 2 commands separated by a semicolon within brackets, followed by a third command outside of the brackets separated by an ampersand. I'll demonstrate some examples of how this can be used to change the order in which our commands get executed. We're running 2 commands inside a bracket separated by a semicolon so that one runs after the other. Then our third command, preceded by a double ampersand, runs upon completion of the first 2, causing all 3 commands to be executed. However, if we change our double ampersand to a single ampersand, it will change the order of execution. Due to our first 2 commands being in brackets, they end up being ran after our third command rather than being ran concurrently like they usually would be when separated by a single ampersand. It's worth noting that all of these techniques can be used in conjunction with each other to allow for more complex operations to take place. In this example, I've got 3 commands all separated by semicolons so that one runs after the other. Then my fourth command is followed by greater than sign so that it gets written to a file. Different combinations of any of these terminal characters can be used to achieve all different types of outputs and can turn basic terminal commands into things that are far more complex if you decide to get creative with them. I will cover some more in-depth examples of this in part 2 of the Linux tutorial series, but for now I am going to move on to various useful terminal shortcuts that can be used. Memorizing and frequently making use of these shortcuts allows us to drastically speed up things that we are doing within the terminal. Personally, I think the most useful out of all of these shortcuts is the scroll buffer, and this is the one that I use the most frequently. By simply pressing the up or down arrows on your keyboard, you can cycle through all of the commands that you executed previously within your terminal session. I will quickly cover each of the known terminal shortcuts alongside the uses of each of them. Ctrl+K will erase the part of the line after your cursor, and Ctrl+W will erase the part of the word in the terminal before your cursor. Using Ctrl+, you will erase a complete line in your terminal. Using Ctrl+C will kill the current process in the foreground running in your terminal. The tab character will attempt to automatically complete the line of text being typed. Ctrl+D will delete the character at your cursor location. Using Ctrl+L is equivalent to the clear command, clearing your screen. Ctrl+Y will paste the last thing that was cut from your clipboard. Using Ctrl+P will go to the previous command in your command history. Using Ctrl+A will automatically move your cursor to the beginning of the line. Ctrl+N will automatically hop to the next command in your command history. Control+E will move your cursor to the end of the line, and Control+R will let you search your command history. Finally, your right mouse key will paste the contents of your clipboard to the terminal. Of course, if you're wanting to start using Linux, the first thing that you will need to do is decide upon which distribution to use. There is no correct choice here, and all distributions have their own pros and cons. One thing to note, though, is that some are a lot more beginner-friendly than others. For example, if you've never used Linux before, then it's probably not the best idea to start out with something like Arch or Gentoo or OpenBSD. Some distributions that are considered beginner-friendly are Ubuntu, Debian, or Linux Mint. Terminal commands, as well as package managers and some other things, will be slightly different based upon the distribution that you're using, and all of the examples given in this video are for Debian-based distros. The beginner-friendly ones that I just mentioned are also all Debian-based, so maybe one of those could be a good choice for you to start out with. It's not a hugely important decision, as you can change your choice of distro whenever you feel like it. However, rather than replacing your current operating system with a Linux distro, it's probably best if you start out with something such as dual booting or running your distro inside of a virtual machine until you're sure that it's the one you actually want to use. Alternatively, you can even run Ubuntu or Kali Linux within Windows these days using WSL2, also known as Windows Subsystem for Linux. With the original release of WSL, you would have only had access to the terminal and nothing else. However, since the release of WSL2, you can now access the entire distro with its full GUI and all of its tools. I would suggest just playing around with a few different ones and then installing the one that you like the most. Then if you get bored of it or decide you don't like it, you can always just switch to another one instead. Finally, something else to take into consideration is your choice of desktop environment or window manager. While your distro of choice will automatically come packaged with one by default, you can always change it out and switch it for another one. This is mostly just a matter of personal preference and is based on whatever you find to be the most visually appealing. However, there are also some performance and functionality considerations to be made, as some are more lightweight and less resource-intensive than others, and some will have certain functionality that others don't have. Changing your choice of DE or WM is a lot easier than changing your entire distro, so you can easily try out a bunch of different ones in order to decide which one you prefer the most. I will show some screenshots of some examples of popular choices just to give you an idea of what they look like visually. In Part 2, you can expect to see many more terminal commands, some examples of advanced terminal usage, Linux installation guides, and how to properly use various package managers. That's all for now. Thanks, and please subscribe.